Hello everyone. Today I want to talk about the medical dataset, stroke. So first here is the data preprocessing of and first we transformed all the categorical features including gender, work type, residence type, and smoking status. And we also encoded other variables, and we created some new variables like we create bins for this age group, like from 0 to 30 is young, and so on. And also we do the same thing for the BMI and the glucose levels and other things also. And this is the data after pre-processing. You can see that there's a lot of new features added. And we also tried to drop some of the uh, unnecessary columns like genders. As long as we have one, I mean, as long as we have one columns for gender, I think that should be fine. That can cover both gender. And also the ID, I see that some of the models uh I have ID in the prediction, so I don't want to see that. So I just dropped this column. So I implemented two models here with a lot of improvement. The first model is the random forest, and I chose both smooth only and undersampling only, and the smooth plus undersampling method for this resampling method. And after improving, I think uh, the hypertuning helps to helps to improve the model a lot. I probably improved this model random forest 5 times. And at first, this model overfit a lot, and I changed to explore shallower trees, change this max depth from 30 to 25 maximum, and I changed the minimum sample split and the minimum sample leaves to make sure that this model uh can help with the overfitting problem. And I also added the CPA for in the model, but that does not improve the model. It generates a lower F1 score. And by looking at the result, I can see that it selects 16 features, and they looks normal, which is everything that I expect, and it generates a F1 score of 95.56%. However, this model, the the last time I improved this model, it had hypertuning and PCA, but it takes about 40 minutes to run. So I don't think it is very efficient. So I think the other model, and this is the learning curve for the random forest. You can see that the training curve keep improving, and uh, the test cost validation score also improves, but at this point it becomes flat. So this one is actually much better. And I fixed the overfitting problem, and this one I think is a well-fitted model. But since it's just not very efficient to run. And in contrast, I think this model, which I updated the code, but this is the uh wait, this is the XGBoost model. And I think this one is actually much better because it's at first I implemented a basic XGBoost model, and it only takes 2 minutes, but the score is much better, and I think this one is very efficient. Uh, and but you can see that this model is still running, and after improving, it also takes forever to run this code. So I think the the basic XGBoost model is already very nice with a nice performance. So I probably will choose XGBoost as my final model, as it generate a very high score in the Kaggle competition. And yeah, I think just XGBoost is much better than the random forest in this scenario, even though that after improvement, they both takes like forever to get the result.